Breaking news. At precisely 0218 UTC today, a routine follow-up observation by the Hubble Space Telescope returned data that immediately forced mission scientists to halt automated processing and switch to manual verification. What appeared on the raw frames was not noise, not an artifact, and not a software glitch. Deep inside the coma of the interstellar object known as 3I Atlas, Hubble detected distinct internal structures, sharp, repeating formations where no structure should exist at all. Moments ago, independent confirmation arrived from ground-based arrays on 2 continents. Today, the impossible just happened. Something we were told was diffuse, chaotic, and temporary is showing signs of order, of design, and this changes everything we thought we knew. If you want real-time updates on the most important cosmic mystery of our lifetime, now is the moment to like this video and subscribe, because what we're about to uncover is still unfolding. When the first alert reached mission control, the reaction was not excitement, but disbelief. For decades, we have understood cometary comas as turbulent clouds of gas and dust, driven by sublimation and solar radiation, inherently unstable and constantly reshaped by thermal forces. But what Hubble saw inside 3I Atlas did not match that understanding. NASA, ESA, and multiple independent research teams immediately began cross-checking the data. Harvard's Center for Astrophysics pulled archival models. Caltech initiated emergency simulations. Within minutes, the European Space Network redirected antenna time. This was not treated as a curiosity. It was treated as a potential paradigm shift. The authority behind this moment matters. Hubble is not alone. The James Webb Space Telescope had imaged 3I Atlas weeks earlier in the infrared, noting unexplained thermal gradients near the nucleus. Atacama's millimeter wave arrays in Chile had recorded intermittent spectral anomalies but dismissed them as transient outgassing. Now, with Hubble's optical clarity resolving inner coma features at scales below 40 kilometers, those anomalies snapped into focus. Observations were being coordinated across North America, Europe, and South America. 3 continents, multiple wavelengths, independent instruments, the same result. The structures were real. 48 hours before today's announcement, 3I Atlas was considered stable. Its heliocentric distance measured 2.14 AU. Its velocity relative to the Sun was 32.7 kilometers per second. Nothing unusual by interstellar standards. Then, 11 hours later, a subtle but measurable deviation appeared in its non-gravitational acceleration, 0.00042 meters per second squared, sustained for nearly 6 hours. Too smooth to be a jet, too symmetric to be random. At the time, analysts flagged it but did not escalate. In hindsight, that was the first sign. 6 hours before Hubble's decisive imaging pass, Atacama recorded a narrow-band emission at 230 gigahertz. The signal lasted 19 seconds, disappeared, then repeated exactly 97 minutes later. No known volatile produces such periodicity under solar heating. When the second spike occurred, researchers overlaid the timing with Webb's thermal maps. The pulses aligned with localized temperature increases of precisely 18 Kelvin, confined to a region less than 60 kilometers across, inside the coma. At 0218 UTC, Hubble's Wide-Field Camera 3 delivered the frame that changed everything. Against the expected diffuse glow, there were concentric arcs, faint but unmistakably sharp, nested around the nucleus. Even more disturbing was their geometry. Each arc maintained a constant separation of 11.3 kilometers, perfectly uniform. No natural fluid instability produces that level of precision in a free-expanding coma. The team recalibrated, they reprocessed, they checked for optical ghosts. Nothing removed the pattern. 3 hours later, a follow-up exposure showed something new. The arcs had rotated, not randomly, but coherently, by 3.2 degrees. The implied angular velocity suggested internal dynamics, not solar-wind interaction. At that moment, one of the senior analysts quietly said what everyone else was thinking: "This looks controlled." Scientific investigation moved into overdrive. Dr. Elena Marsh at Caltech led the first full gravitational and radiative modeling run, incorporating solar pressure, outgassing forces, and dust grain dynamics. The result was blunt. No combination of known cometary physics reproduced the observed structures. Dr. Anil Verma at Harvard ran spectroscopic inversions, isolating molecular signatures within the arcs. The composition differed from the surrounding coma, enriched in complex carbon chains, depleted in water ice. That alone was unprecedented. Two hypotheses emerged. The mainstream explanation argued that 3I Atlas is an extreme outlier, a highly processed interstellar remnant with layered volatile shells exposed sequentially as it warms. Under this model, the arcs are transient phase boundaries, rare but natural. It is a comforting idea. It preserves physics as we know it. The alternative interpretation is more troubling. It suggests the inner coma is not simply venting material, but organizing it, that the structures are not byproducts, but components. Under this view, energy is being distributed selectively, shaping matter with intent-like efficiency. No known law of physics forbids this, but none predicts it either. Debate intensified when a second wave of anomalies arrived. 12 hours after the first arcs were detected, one segment vanished completely. Hubble, Webb, and Atacama all reported absence across optical, infrared, and millimeter bands. There was no dispersal plume, no thermal spike. One moment it was there, the next it wasn't. Simultaneously, magnetometers aboard Earth-orbiting satellites registered a brief disturbance, 0.6 nanoteslas, localized, lasting 14 seconds. Too small to cause damage, too precise to ignore. Then came the alignment. Analysts mapping the rotational axis of the inner structures noticed a slow drift, not toward the Sun, but toward the ecliptic plane, toward Earth's orbital path. By itself, alignment means nothing, but when combined with the timing of the electromagnetic disturbances, the pattern became harder to dismiss. This was no longer random, it was responding. Inside control rooms, the mood shifted. Conversations lowered, screens multiplied. Data access logs spiked as agencies quietly pulled information behind classified firewalls. An internal ESA memo, later leaked, used the phrase non-passive behavior. NASA issued no public statement, but postponed a scheduled press briefing. Silence in these moments speaks volumes. Globally, the effects were subtle but measurable. 2 communication satellites experienced brief signal degradation over the South Atlantic. Long-range radio operators reported unexplained noise bursts. In Northern Europe, migratory bird tracking systems recorded deviations in flight paths coinciding with the magnetic disturbance window. None of this proved causation. All of it raised eyebrows. As the hours passed, the initial fear gave way to something quieter, awe. We have always assumed that interstellar visitors are relics, rocks, ice, debris from distant star systems, passive messengers of other places. But what if that assumption is wrong? What if some objects are not merely traveling through space, but doing something while they travel? I remember staring at the data feed, watching those arcs rotate with silent precision, and realizing that for the first time, the universe was not just throwing randomness at us. It was offering structure, maybe even communication, in a language we barely understand. This does not mean 3I Atlas is a machine. It does not mean intelligence in the way we define it. But it does mean that our categories, natural versus artificial, random versus designed, may be too small. The cosmos has always been more creative than our theories allow. As we move forward, new observations are already planned. Hubble will continue high-resolution monitoring. Webb will probe deeper into the thermal core. Ground arrays will listen for patterns in the noise. Every hour brings new data. Every dataset raises new questions. And so we end tonight not with answers, but with a threshold. Inner coma structures are real. They are stable. They are precise, and they should not exist. If this is natural process, it will force us to rewrite cometary physics from the ground up. And if it is not, if this represents something entirely new, then we may be witnessing the first hint that the universe is not just full of matter, but of behavior. The final image from Hubble, captured just minutes ago, shows the arcs dimming, not dispersing, but folding inward, as if conserving energy, as if waiting. What happens when it changes again? Subscribe to follow the next update, because this story is not over.